Hi guys, welcome to this video looking at converting recurring decimals into fractions. We've got two past paper questions here we're going to have a look at, worded slightly differently, but the technique's going to be the same for both of them. So let's make a start and let's have a good starting point looking at this key term here, recurring. A recurring decimal is one that doesn't terminate, so it's the opposite to a terminating decimal. A terminating decimal has an exact value. So for example, if I had the decimal 0.1, which is equivalent to 1/10, that's a terminating decimal. It has an exact value, 0.1, no more, no less. If I had alternatively 1/9 and I turned that into a decimal, that would be 0.1111 and so on and so on and so on and so on, which we end up writing as 0.1 recurring. So a recurring decimal is one that keeps going with kind of like a pattern of numbers occurring over and over and over again. The thing that I kind of alluded to there that we need to talk about in this question is this dot notation, and these dots indicate which numbers are recurring. So what we have here in this question is a very special case where we actually have a number that's both terminating and recurring, because the 0.2, so this digit here, the one in the tenths column, is the terminating part to the decimal, and the 8 and the 1 are the recurring part. So this decimal actually says 0.2, 81, 81, 81, and so on. It's the 8 and the 1 that recur as the pattern. The 2 just appears once as a terminating part. So let's learn how to convert this into a fraction. And what the exam's looking for is whether we can come up with a general model, an example to make this work in all situations. And in maths, when we come up with general models, when we come up with examples, we tend to use algebra. So I'm going to start by calling the recurring decimal that I want to convert x. You could call it any letter if you want. You could call it n, you could call it a, but I'm going to choose x because that's a common letter to use in algebra. So I'm going to call 0.281 recurring x. Now there's a rule with recurring decimals in terms of turning them into algebra, and the number of recurring places gives you how many powers of 10 you're going to multiply the number by. So I'll come back to that in a minute. So I've got x, x is equivalent to 0.281 recurring, and the first thing I'm going to do is I'm going to times that by 10. So x times by 10 is 10x, and 0.281 recurring times by 10, so make it one decimal place bigger, is going to become 2.81 recurring. Now, what we're looking for is to try and be able to line up the recurring decimal places so that they can be eliminated by subtraction. So, as it currently stands, if I line these numbers up, the 8 lines up with the 2 in the tenths column, the 1 lines up with the 8, and so on and so on and so on. So I haven't managed to line them up yet. They're not lined up in terms of the 8s being in the same column and the 1s being in the same column and so on. So instead of timesing by 10, I'm going to try timesing by 100 instead. So I go back to my original x value and I times it by 100. So that gives me 100x, and 100x multiplied, 100 multiplied by 0.281 recurring. That means I'm going to make it 2 decimal places bigger. So that's now going to become 28.18 recurring. So think about that 8 and that 1 feeding through each time. Again, no way of lining any of those up so that we can eliminate the recurring part. So I'm going to go again, and this time I'm going to multiply by another power of 10. So I'm going to multiply by 1,000. So that gives me 1,000x, and 1,000x is going to be, if we have a look at that, moving it 3 decimal places, that's going to give me 281 and then the 81 recurring part. Now, what you might be able to spot here is that the 10x value, so the value that's 10 times greater than the decimal we started with, and the 1,000x value, so a number that's 1,000 times greater than the decimal that we started with, have both got their 81 recurring lined up. So if I lined these up using kind of like a place value column, I would have my 281.81 recurring value, which represents my 1000x, and I would have my 2.81 recurring value, which represents my 10x, and I can here by subtraction now eliminate the recurring part. So 1 recurring subtract 1 recurring is 0. And remember, all of the other recurring places after this number are also going to now cancel each other out. 8 recurring subtract 8 recurring is 0. I've now got 1 subtract 2, which I can't do, so I'm going to have to borrow from the next column. So that gives me 9. 7 subtract nothing, and 2 subtract nothing gives me 279 as an exact value. On the right, in terms of the x's, I've got 1,000 x's, and I subtract 10 x's, so I'm left with 990x. And now if you think back to the start of this question, we wanted to talk about what x was. X as a value. I've currently got 990 x's, but I want to talk about one lot of x. So I'm going to have to divide by 990 to get rid of this. And as we know with equations, we do the same thing on both sides. So I'm left with here that x is equal to 279 divided by, and we'll write that as a fraction, divide by 990. So what I've done is I've taken a value of x as 0.281 recurring, turned it into an equivalent value of x of 279 over 990. So if this is equal to x and this is equal to x, it would be reasonable to say that they must be to each other. So 0.281 recurring must be equal to 279 over 990. It then says to us back at the original question, cancel this down into its simplest form. So we need to kind of think about a number that can be divided into this, and we need to think about a number that can be divided into this. I know that they can both be divided by 9, and so 279 divided by 9 and 990 divided by 9. So my simplest fraction is 31 over 110. Now let's have a look at a second question and see if we can practice following the model that we've just used there. You'll notice with this one that the wording of the question is different, but actually it's the same type of structure and it's going to be the same process that we're going to follow. We've got another recurring decimal. This one's 0.045 recurring, so it's exactly like the first one. We've got a terminating part and a recurring part. The question, however, has already given us the answer, we believe, which is 1 over 22, and we've got to go through this process to show how these can be kind of equivalent values. So, the question's already started with, like we did on the first one, calling the recurring decimal an algebraic term, x. So if x is equal to 0.045 recurring, let's start by timesing that by 10. So 10 lots of that's going to mean move that one decimal place bigger, so that's going to give me 0.45 recurring, so they don't line up yet because the 4 lines up with the 0, the 5 with the 4 and so on. So let's times by 100, so that's going to give me 100x, and that's going to make my number now 4.54 and obviously the recurring part. Nothing lining up yet that's equal. Let's times that by 1,000 then, let's keep going one kind of power of 10 bigger each time, and that's now going to give me 45.45 recurring. And you'll notice that we now have a scenario where two of our values can have the recurring part of the decimal lined up to eliminate. So we end up with our 1000x value being 45.45 recurring, our 10x value being 0.45 recurring, and if I subtract these away from each other, both parts of this kind of equation here, on the left I'm left with 990x, and on the right I'm left with exactly 45. Our last stage is always to try and get this down to one lot of x so we can make it kind of comparable to our original part of the question. So I'm going to end up with this time x is equal to 45 over 990. So we think we're there, but the question's asking us to prove that it can be expressed as 1 over 22. So we're probably thinking now, can we make this equivalent fraction to 1 over 22? Can we cancel this down? Well, the first thing I can see is that both of these numbers are divisible by 9. So 45 divided by 9 is 5, and 990 divided by 9 is 110. I can still see a common factor that I can divide through by, which is 5. So 5 divided by 5 is 1, and 110 divided by 5 is 22. So where we end up with, in terms of our proof, is that x is equal to, at the beginning of this question, 0.045 recurring. X is also equal to 1 over 22. Therefore, 0.045 recurring is equal to 1 over 22 because they're both values of x that can therefore be made equivalent.